So if I have 2x to the power of 5, we would say that this has a degree of 5. So what we're doing is we're looking at the exponent on the variable. That's what the degree is the exponent on the variable. Negative 2 divided by 3, ab cubed c squared has a degree of, well, on 2/3, I have a degree of 1, plus this 3, or sorry, on the variable. So a has an exponent of 1 on it, b has an exponent of 3, and c has an exponent of 2. So 1 plus 3 plus 2 is equal to 6. We would say that negative 2 cubed ab cubed c squared has, or negative 2/3 ab cubed c squared has a degree of 6, where I just add up all the exponents. So the degree of a polynomial is given by the term or monomial with the highest degree. So as an example, if I have 3x squared y squared minus 2x4 plus y, or xy to the power of 4 minus 2, we would say that this has a degree of a combination of these ones here. That would be 1 plus 4, or a degree of 5. If a polynomial has a term with no variable present, this term is called a constant term. In the polynomial 3x squared y squared minus 2x4 plus x4 minus 2, the constant term is negative 2. This is the only term in this polynomial that doesn't have a variable attached to it. So depending on what the variable actually is, there's no, once substituted, that negative 2 is never going to change. It's going to remain constant. Class example number 4, we want to state the degree of the following polynomials. So remember, we always go by the largest degree on the variable, and that would be this one here. This has a degree of 4. This next example is a little bit different because we have, each term has 2 variables with the exception of this one. So here we would add our degrees. So I have 2 plus 3. That would give me 5. However, 7 plus 1 here, this would give me 8. So this polynomial has a degree of 8. Next we have class example number 5. Give an example of a binomial of degree 1 in one variable. So we want to have a binomial, so it has to have 2 different terms of degree 1. So here's the variable, one type of variable, x minus 7. So a degree of 1 different variable, and it's a binomial, 2 terms. A trinomial in 2 variables with a constant term. So a trinomial in 2 variables with a constant term. We could have x plus 2y minus 7 again. Constant term, 2 different variables. And it's a trinomial, 3 different terms. A monomial of degree 6 with a numerical coefficient of 9. So 9 in front of the variable, and we could go 9x with a degree of 6. A binomial of degree 8 with each term containing 2 variables. So we can go x, y, and we want to have a binomial plus 2. We could go x, y again. We want to have a degree of 8. So we could say 5 and 3, and then we could have 2 and 1. And let's change this to A and B, so we don't have to add anything up there. All right. So this list contains classifies polynomials by using the degree of the polynomial. So a constant polynomial has a degree of 0. So an example here would be 8. A linear polynomial, so one that would form a straight line, has a degree of 1. Example, x plus 3. A quadratic polynomial has a degree of 2, so x squared minus 2x plus 5. And it's showing them these ones as polynomials and trinomials, but you could also have a quadratic polynomial that has one term as an example. A cubic polynomial has a degree of 3, a quartic polynomial has a degree of 4, and a quintic polynomial has a degree of 5. So there are names of higher degrees, but we're not going to be looking at those. So class example number 6, complete the following table. My polynomial expression 4xy minus 6, and we want to express what the degree of this polynomial is going to be. So first of all, xy, this would be a degree of 2. So classification of the degree, if it's a degree of 2, that means we have a quadratic. And the constant term here is 6. Next, we have a degree, we look at the highest polynomial, that's this one here. And this has the degree of 3, which means this is a cubic polynomial. And there's no constant term here, so constant term we'd say is 0. A polynomial in a single variable, these are usually arranged in ascending or descending order. The leading coefficient of a polynomial in a single variable is the coefficient of the term with highest power of the variable. So we'll look at, that's pretty wordy, but we're going to break that down in example number 7. So consider the polynomial expression 2x minus 4x cubed minus 7 plus 6x squared divided by 5. We want to write this in descending powers of x. So we want our powers of x to get smaller. So first of all, my largest power of x is this negative 4x cubed. Negative 4x cubed. My next highest degree on my x is the 6x squared, and that's positive 6x squared fifths. So 6x squared over 5. Next, I have positive 2x, and then my last term, which is negative 7. Now we want to reverse this and write it in ascending powers of x. So negative 7 would go first, followed by 2x, then my 6x squared divided by 5, and then my negative 4x cubed. We want to state the leading coefficient and the constant term. So the leading coefficient is the coefficient that's attached to the highest degree. So leading coefficient would be negative 4, and the constant term is the one that does not have a variable attached to it. That would be negative 7. And then we want to state the numerical coefficient of the term in x squared. So the term in x squared was 6 fifths. Not just 6, but 6 over 5.